Hi. Okay, so just quickly copy the graphs. I'm going to start capacitors today. Page 106. Yeah, somewhere in January. Chapters not many, but topics a lot. So we have magnetism, we have AC currents, we have quantum physics, we have nuclear physics, we have medical physics, and astrophysics. However, magnetism has like 3 divisions to it, and those divisions are like chapters. So you could say 3 more. So magnetism is a bigger hurdle. If we are done with magnetism, you can consider syllabus 80% done. Of all the chapters out there, like the rest of them, students struggle with quantum physics. Though it's very easy, it's just a very strange idea. That's why it's difficult to grasp. And some students don't like medical physics because you have to memorize working of 5 medical equipment. Each of them are 10 marks. Just memorize. There's nothing to really learn. But 10 marks are answer short. I mean, yeah. If you are willing to study, it's a good chapter. But if you're just willing to understand, it's not a good chapter. Yeah, exactly. It's like peek into what bio looks like. I hear. I enjoyed bio in all of those. I know it's something different. It's like O-level waves and A-level waves. Oh, really? Why do you put yourself through it? Because I always warn students, bully, that bio forget the other subjects. If you want to do well. Somebody took my advice differently this time. She shop cherry the bio accessory. There are few. Subject na math. Math to basic lagbe. So math and bio. Maybe pharmacy.
What can you do without math?
Without math. Computer science, maybe. No.
Minus a basic subject.
No, if you just have physics, you must have some math to know, right? So I think you can do a lot of things. No. Physics?
Just physics and math.
There's a lot of subjects out there. I think 80% of the engineering is just physics and math. No. There are a lot of engineering where you'll never even pick chemistry. Chemistry it's called a departmental subject. That's like the introduction of an accounting, economics, chemistry. No. Unless you go into material science. That's the deformation chapter of AS. Does that, I get to know. Okay, so let's move on. So we're done with graphs of electric potential. I want to start a new topic. So we'll start our next topic, capacitors. It's a bridge between electric fields and electricity. Okay, so it's a device that uses properties of electric field, but it's a standalone chapter. So if you didn't understand electric field, right, nothing makes no difference here. You can still understand this chapter. Okay, electric field link night, but yes, it's a device that utilizes electric field. Okay, so what is a capacitor? What is capacitance? Energy stored, discharge. So these all are combined. You can unfortunately to break down the so I'll be doing like this one here, then this one, then this one, but eventually shop will actually take over. Okay, so yeah, what's a capacitor and why do we have it in our A2? So capacitor is an electrical component. So let's start with the basics. Okay, it's just like a resistor, LED, LDR, thermistor, or capacitor is an electrical component. And this component is very unique. And the reason why it's unique is because it's very versatile. So I can say for sure, right, that it has a capacitor inside it. There might be an LDR, there might be an LED, right? So this remote doesn't have an LED. There's light Jolinato, right? But I know for sure what's inside this, a capacitor. So why are capacitors so sought after in electrical appliances? So the main reason behind that is capacitors can convert alternating supply to DC supply. And that's a very important thing. Why? Because all our homes run on AC supply, right? But all our devices work on DC supply, most of them. Okay, so just maybe the lamp in your house will work on an AC supply, but DC. So you'll find that anytime you buy an appliance, you'll have to get one of these. It's a power brick, right? A power breaker it's a transformer and a converter. So transformer to keep for it. Transform the high voltage in your house to low voltage, right? So this one is how much? 20 volts. So Basha supply 220 volts. So it's a step down transformer here. But it also says here it's a DC supply. So, but our house supply is a what supply? AC supply. So AC ke DC capacitor lage. And one of the earliest use of capacitors that most people know of is in the fan. Because a fan is a motor, and a motor will only exclusively run on what supply? DC. And if you remember, motor had one directional rotation. Or AC ke DC convert capacitor. So that's one very good use. And that alone should be enough for capacitor to be considered a very useful component, right? But it has even more advantage. Capacitors can understand time. So, if I have a resistor, if I have a thermistor, there's no concept of time there. And the time doesn't have a function there. Capacitors can be timed. I can take a capacitor, I can store energy in it, and then I can let that energy go out of the capacitor in a time that I set. I can set that time, which change in my, changing my circuit and whatnot. So capacitors are the first electrical appliances that can understand the concept of time. So you can put a time function to it. Okay, so using these two things, you'll eventually find that almost everything needs a capacitor. So for example, appliance থেকে time off হয়ে গেলে off হয়ে যায়, থাকে না timer থাকে, and it like turns off on itself. TV হয় মাঝে মাঝে, you're not watching it for long enough, it just shuts down, right? It has a capacitor inside it, and what happens is the capacitor has a value, and then what happens is that value keeps decreasing. At a point is zero হয়ে যায়, তখন off হয়ে যায়, is discharging a capacitor. Our example of a capacitor, very famous one, is the ovener J timer থাকে. It's actually a capacitor. It's actually a variable capacitor. So every time you change the time on an oven timer, you're actually changing the watt of the capacitance. And by changing capacitance, you can change the what the oven does, the time it lasts. Okay, so that's how it works. And one more relatable example of capacitor, which is cabin lights in your car. So গাড়িতে দেখো যখন তুমি door off করো, ভিতরে যে cabin lights গুলো থাকে, some modern cars I think হচ্ছে যদি aftermarket কিনো off হয়ে যায়, like instantly. But traditionally, they're supposed to dim the off, right? You notice this, they go up on the proper, it just dims and closes. And in some high-end cars, it's like a very smooth transition, right? And if you buy like a aftermarket one, it's like off, a sudden off with it. So dimming effect is done entirely by a capacitor. We'll learn that. We have a math based on that. Okay. So yeah, what is a capacitor? It's an electrical appliance or component, and it has versatile uses. So let's say you go into electrical engineering, right? You'll find capacitor is almost there in every circuit you make. Capacitor, resistor, and diode. You can do anything. In fact, computers are entirely built on what? Diodes. Just semiconducting diodes circuit eventually there is a thing called a transistor. আর তোমাদের সিলেবাসের মধ্যে দেখবা এরকম একটা ডায়াগ্রাম থাকে, সিলেবাসের মধ্যে না, question paper, if you go to some past paper, এই যে this এগুলো আমাদের নাই কিন্তু, you're very lucky. It is one of the worst chapters ever created. It's called an operational amplifier. নামটাই হচ্ছে strange. Okay, so this operational amplifier is an electrical component. It's just a combination of what inside, series of capacitors, resistors, and stuff inside. It can do a lot of things. It can amplify sound. It can change the way your wave looks like. It amne aage slow chilo, and students didn't like it at all. Okay, so thankfully they got rid of it. So yeah, capacitor once again is an electrical appliance. So what are the few introductory ideas about the capacitor? So yeah, not transformer. So they don't change the amount of voltage. They can change AC to DC. So they're basically a converter. They convert AC to DC, or yeah, that's it. For transformers, you need a transformer. Okay. Yes, diode also does that, but diode does it in a way that's very inefficient. So just a quick reminder, if you have an AC supply and if you place a diode in your circuit, right, how would this look like? Remember, it was called half-wave rectification. মনে আছে যে ডায়োড যদি দিতে এসি সাপ্লায়ার হচ্ছে যে একটা সাইকেল ক্যান্সেল আউট হয়ে যেত আর আরেকটা সাইকেল খালি বাকি থাকতো, because diode only allows current to flow in one direction, right? So yeah, is this a DC supply? Yes, but is it a DC supply that you're aware of typically? No. What's a DC supply that you typically know of? It's a straight line, right? So eta করার জন্য you need capacitor. So I can convert an AC into DC, and this is very inefficient because half the cycle to me right away কি করছো, destroy করছো also. On top of it, isn't it not fluctuating a lot, right? So if you want to make it a straight line, I need a capacitor. There's a name for that process called smoothing. So this it's a very elaborate thing, and only question correct. Okay, so yeah, we'll get to that in a minute, but let's start with some basic facts about your capacitor. So capacitor symbol is this. It's two lines parallel to each other. This is the symbol for capacitor. However, there is also a symbol for capacitor that you'll find in textbooks and other places, which is there's a curve line and a straight line. So curved line or straight line are a capacitor difference. So this is also the symbol for a capacitor. So capacitors don't have any polarity like a battery. Battery, the taller one is what polarity? Plus, right? And the shorter one, minus. Turns out almost all capacitors are non-polar. Non-polar মানে কি কোনো plus minus যেভাবে যাও use করার problem নাই. However, some capacitors are polar. যেখানে এটা plus থাকবে আর এটা minus থাকবে. And surprisingly, the capacitors that you find in the market, they're all polar. Non-polar টা খুবই rarely পাওয়া যায়. How would you know so? And how do you know if your capacitor is polar or non-polar? So there's actually a convention they use in electrical appliances. Capacitor এরকম দেখতে হয় একটা সিলিন্ডারের মতন, and দেখবা নিচে দুইটা হচ্ছে terminals থাকবে. If your appliance has two outputs that are equal length, it is non-polar. But you'll find that anytime you go and buy a capacitor in the market, it looks something like this, which is a what capacitor? Polar capacitor. Okay, what's the difference? Difference হচ্ছে polar capacitor plus and minus matter for it. So if you connect your battery plus to the plus, it works. But if you connect your battery plus to the minus, কাজ করে না. So polar capacitors, the direction matters. We don't have it, but you have it as a, whenever you use it in real life, you'll probably have a polar capacitor. Okay, so yeah, that's the symbol for capacitor. Question থাকলে বলতে পারো. And the next thing that we have is what is the symbol? So symbol for capacitance is C. C is capacitance, and it is measured in the unit called farads, F-A-R-A-D, named after Faraday, and it's your capital F is the symbol. Okay, and capacitance is a very small value, so you'll find that typical capacitances of appliances and devices, they're in the range of what? Nanofarad, picofarad. These are common values. So if you get like a very small value for capacitance, that's normal. That's how it's supposed to be. 5 capacitance, 5 farad, it's like almost impossible. It would be the size of this room. Okay, so typically capacitors that have capacitance of nanofarad and picofarad, that's natural. Okay, so yeah, that's what you have to know about capacitors. And I'll show you a couple of pictures, a little bit idea of it, and then I'll show you how it works. So I'm the key jante hobe capacitor ব্যাপারে everything. Okay, the way it's constructed, how does it work, where does the charge flow, what is it made up of, সব কিছু. Okay, so capacitor মধ্যে there are 2 main categories out here. You have one, which is the one we're going to study. It's called a parallel plate capacitor. Okay, so explain grade 2. The one we'll be doing is called the parallel plate capacitor. And the one that normally is found in the market is not the parallel plate. It is the spiral capacitor. Okay. So parallel plate capacitor, the name kind of gives it away. It's 2 watt parallel plates. Okay, so yeah, these are parallel plates, and that's called a parallel plate capacitor. And capacitor designer মধ্যে there is a math involved which they remove from your syllabus. আমি ওটা পড়াবো না, but the gap between the capacitor is very important. The gap between the capacitor is an insulation. So capacitor parallel plate মাঝখানে insulation place করা হয় এরকম, and this insulation is very important. Okay, I'll explain in a minute why. This insulation has a name though. It's called the dielectric. And dielectric is the scientific term for an insulator. So insulator normally right? What is an insulator? Something that doesn't conduct, right? But the scientific name for a insulation or insulated material is called dielectric. And dielectric air. Air is a very good insulator, right? But turns out air is not the best insulator. Can you give me an example of where air fails to be an insulator? Tesla's experiment. Which one? Okay, but anyone else, can you give me an example where air, which is marketed as very good insulator, actually fails? Yeah, lightning strike. Lightning strike from the sky, right? From the clouds. Cloud ticket goes and hits the ground. What's in between? Air. And it was supposed to insulate you, right? But it did conduct. So there's a point where the air breaks down. When it turns into ions, right? So we don't use air. Ceramic use করা হয়. So do you know what ceramic is? It's just basically mud, soil একটা জিনিস করা হয়. Ceramic is an excellent insulator. There's absolutely no way ceramic will conduct anything ever. It just doesn't have that mechanism. Okay, a very good example of your dielectric is oil, some insulating oil out there. Okay, so yeah, the point I'm trying to make here is that তোমাদের যদি কোনো capacitor পাও and you break the capacitor open, right, you'll find 3 things can come out. Sometimes nothing, which means what was there? air. Sometimes you'll find there's a white powder. What is it? Yes, ceramic, right? And sometimes you'll see there's oil coming out, and that oil is that liquid. Okay, that the liquid that is dielectric. Anyways, these are two types of capacitor out there. What's a spiral capacitor? I'm the syllabus and but so it's a capacitor where you have a metal plate that's wound into what? A spiral. And it a করে কেন তারা? So it turns out capacitor area jodi বাড়াতে পারো, if you can increase the area of your capacitor plates, right, it becomes more effective. So if I have more area, I will have a better capacitor. But you know, the problem with bigger areas is that the capacitor size increases, right? So ওরা যেটা figure out করছে that if you make spirals inside like this, right, wouldn't you be able to squeeze in more area of the plate? Again, if you wind inside like that, so your spiral capacitors, cylinder moton dekhte hoy, if you unwind them and then you know roll them out like that, they can be that big because you know they're spiraled and coiled up inside, right? So it's a very big plate out there. As you parallel plate with it, they have to work a capacitor. Okay, so anyways, these are different types of capacitors we have. I mean, only the diagram dekhachhi in a minute. So this is basic introduction. This is an introduction for someone who will just want to know what the capacitor is, not how it works. So I'll show you in a minute everything else. So let me show you some pictures of capacitors out there. Right, so these are capacitors. So if you buy capacitors, they এই টাইপের থাকে তোমার হচ্ছে different shapes and sizes. Most of them look like cylinders here because they're what capacitors? Spiral capacitor. আমরা যেটা করতেছি ওটা খুবই you know not very effective. These are what capacitors? Parallel plates. Okay, so inside খুলে দেখবা দুটো parallel plates থাকে. Okay, but এগুলোর ভিতরে there's lots of spirals, which is more effective. Right, so what does a capacitor actually do? So if somebody asks you, let's say তার কোনো physics or knowledge নাই O level পর্যন্ত, and they ask you what does a capacitor do, what would that answer be? So capacitor in essence is an energy storing device. That's what it does. Energy storing device. Okay, so it's basically storing energy. Now, how does it store energy? It stores energy using what? Using charges. So using charges. It's a common mistake where students will think capacitors are what device? Charge storing device, which is incorrect. And they'll ask you this question very often, that explain why capacitors are not charge storing devices. They don't store charge. And if they even store charge, right, what benefit does it have for you? Charge the key we can make use of what inside the charge? Energy, right? So capacitors at the end of the day are what devices? Energy storing devices, right? So just be aware of that. So charge movement correct, but what is that movement eventually leading to? Storage of energy. Okay, so we can say capacitor is like a battery because a battery also stores what? Energy, right? The only main difference is a battery stores what energy? Chemical energy. A capacitor stores what energy? Electrical energy. Okay, so capacitor electrical energy store করে electrical energy দেয়, battery chemical energy store করে electrical energy দেয়. There are some advantages of electrical energy to electrical energy. Okay, so let's try to understand the working of a capacitor. How does it work? So this is going to be like a basic introduction to never detail lage, so detail আমি একটু পরে দেখাচ্ছি. So if I have a capacitor, how does it work? Like a very basic version of it is if I directly jump into the intricacies of the process, confusion of it. So I'm going to just like a simple explanation day. So capacitor, কোনো নিজের এনার্জি নাই, সো এনার্জি দিতে হয়, এনার্জি দেওয়ার জন্য কিসের সাথে কানেক্ট করতে হবে? আ পাওয়ার সাপ্লাই। সো ক্যাপাসিটরকে কিন্তু হচ্ছে এনার্জাইজ করতে হয়, and you need what to energize your capacitor? A power supply. So you first have to charge your capacitor. There's a term out there, and it had to I mean, it's probably not relatable, but camera flash, camera the flash thing. Have you used camera flashes, not in your phone, in a camera? What disappears? Oh, the bulb. It disappears. around the bulb. Achha, are you talking about separate flashes, like attached flashes? Achha, so let me to clarify, Corey. I'll go back to explain, because capacitor, one of the first ever used was a camera flash. I'll explain in a minute. But if you go for professional shooting, right? Somebody has a separate flash. ওই umbrella থাকে, umbrellar মধ্যে flash দিয়ে রাখে, right? Forgot the name, key box জানি একটা, some box, okay? So anyways, there's a flash out there, and flash গুলো charge করতে হয়, and এবার buttons থাকে, buttons দিয়ে এবার charge হচ্ছে. Those flashes are just giant capacitors, and what they do is they store energy in them, and then once you want to take a picture, as you press your shutter, right, it releases all that energy in the form of what? Light, right? Now, why can't you do that with a battery? So the problem is, if I take this battery here and I connect it to my flash light, my camera flash, right, it has a lot of energy out there, but there's a small problem. It will release the energy at what rate? Really, really slow at the rate. So it's glowing for days, right? But I wanted light instantly. Capacitor advantage key, you can actually control the time over which the light will be given. So if I want a camera flash, I want my time to be what? Very short. If I want like a cabin light in a car to dim down, time down to barabo. If I want the light in a room to slowly die out as the night goes by, I would want longer, right? So you can control all of that. Can you do with this? No. Yes, this will die out, but not because you wanted it to, because it just died out, right? Because the energy change. So camera flash is a very good example of capacitor. So I'll show you how it works. So I'm ki korbo, I'll take my capacitor, I'll connect it to a battery. Now, the first thing that will happen right away is that this is a positive terminal of your battery, this is a negative terminal of your battery. What will they do to the charges on the plate? So what would the positive do to the charges on the plate? It's a metal plate. A metal plate has plenty of free flowing electrons. So what would the positive charge do to the electrons? Attract it, right? So you'll start to notice from that other plate on the other side, there are charges here, right? You start to notice that these electrons here, they're moving and they're coming this way. But as the electrons move out from here, aren't there electrons on this side as well? What do those electrons do? Get repelled and they'll go there. But the electrons go here for two reasons. Number one, they're getting what by this supply? Repelled. And they're also getting what by the other plate? Attracted, because this plate is now what charge? Positive, right? So what will happen is, gradually, what will start to build up here? Charges. So charges ashbe, and the charges will bring what with them? Energy. From where? The battery, okay? So that side will become like, some charge, negatively charged, and this side will become equally what charged? Positively charged, right? I have a very simple question for you, okay? Did we add charge to our system? Did we remove charge from our system? Or the charges are the same, they just got redistributed? Redistributed, because I didn't add any charge here. A battery doesn't provide charge. I hope you know that. A battery provides what to the charge? Energy, right? So I have provided charge, I've provided energy to the charges, and the charges got redistributed. So if I add all the charges here, you'll see it's the same value as what? The original, don't change 9. However, these charges right now possess what in them? Energy. How is that possible? So it's an analogy. So capacitor is almost like this, okay? You have this ramp, and there's the ball that you take up the ramp. So to take the ball up the ramp, what do I need to do on the ball? Work, right? So I apply work and the ball goes up there, and it's storing what energy right now? Gravitational potential energy, and it's there. The ball will fall and will give me back the energy. That's exactly what's happening here. We are doing work on the charge, and we're pushing the charge up to a high potential, and the charges are held there. And যখন তুমি charge গুলো ছেড়ে দিবা, they'll just fall back. And as they fall back, what will they give back to you? The energy. It's very similar to a hydroelectric power station. You know how the water is raised to a height, and you let go of the water and it falls and gives back energy to you, right? So yeah, this is now a what capacitor? Charge capacitor. I will take my charge capacitor, right, and I will disconnect it from the circuit. My circuit থেকে খুলে ফেলবো, মানে battery থেকে. And now what I'll do is I will connect a what here? Camera flash বলছিলাম. So I'll connect a lamp here. What will happen now? So before we move on, can you tell me, these are negative charges, right? And on the other side, you have what charges? Positive charges. Can you tell me a negative charges গুলো কই যাওয়ার চেষ্টা করতেছে towards the positive, right? And they're very eager to go there, but who's stopping them? Yeah, dielectric, right? So if the dielectric is not strong enough, it'll fail and the system breaks down, right? So এখন ওরা এদিকে যেতে চাচ্ছে বা যেতে পারতেছে না because there's an insulator out there. ওরা এদিকেও যেতে পারতেছে না because what's there? A negative terminal and there's a positive terminal. However, if I get rid of the battery, they still can't go that way, but they can go somewhere else though. Which way? The other way, right? So all these charges that you see here, these electrons which are like eager to go there, they'll instantly just go that way to that side and neutralize the system. While doing so, while they travel this way and that way and they pass through the lamp, they convert the electrical energy they had as what energy? Light. And suddenly you'll see this lamp here glows, right? Now, do the charges move very slowly or do they move very rapidly? Very rapidly, right? So the lamp will glow for what duration? A short duration, right? Now, what if your capacitor is like extremely big in size, like, massive in size? Again, charges will flow, right? Through the same lamp. Do you think they'll flow in the same duration? Will this take longer? Yeah, it can't take longer, right? Just imagine I have a glass and I'm releasing the water of the glass into a pipe. It takes 10 seconds. Now I have a water tank that I'm releasing into the pipe. Wouldn't it take like a few hours? And then I have a swimming pool out there. So the point I'm trying to make here is that the more charge you have, the longer what the process would be, the discharge process, right? So that's what a capacitor does. Now, you know what students sometimes complain? To the battery, they directly project. Why do this whole process of take energy from a battery into a capacitor, then capacitor to a lamp? Can anyone answer this? Thing that we do. Why do we do this? Why do we take from a battery to a capacitor, then capacitor to a lamp? We could have just bypassed the capacitor and done this directly, right? So can we capacitor ke process include kora hocche? Right? Okay, almost there. So the reason is you can't control the rate of energy transfer using a what? Battery. But with a capacitor, you can control the rate. তুমি চাইলে কিন্তু লম্বা করে ফেলতে পারো. It is possible for a capacitor to discharge in such a slow way, right? It will outrun the time taken by a what? Battery. So যে সবসময় ভাবো যে battery slow, capacitor fast, তা না. Main advantage টা কি এখানে? You have control. You can pinpoint precisely, exactly set the time taken for your thing to discharge and charge, right? So I'll show you a simulation of this. See, okay? So the working of a capacitor. This is like a very straightforward and very useful like the simulation, right? So key hocche ekhane to explain for you. Look at this. You have a battery on this side, a battery, and the voltage in the battery is 0 right now. This capacitor ekhane plate guloke dure kache ana jay, boro choto kora jay. Okay, these are like variations that's out there. You'll see at the top there's a capacitance ticked box and it says 0.21 watt at the top, picofarad. Ami jodi plates guloke kache ane, what do you think would happen to the ability to store charge? Increase or decrease? If your plates are closer, will more electrons be eager to get into the plate, or less electrons will be likely to go to the plate? More, because the closer you bring your plates, aren't these positively charged? Wouldn't that attract more electrons out there? So দেখবা যদি আমি প্লেটস গুলো কাছে নিই, দেখো উপরে ক্যাপাসিটিটা বাড়তেছে, right? Our article could be obvious. If I have small plate versus large plate, wouldn't the capacitor be directly proportional? Small plates will have less charge on them. So let's try something, okay? Let's take a very big plate and place them very close together. That's the highest capacitance combination, right? 1.77. And then what I'll do is I'll charge my capacitor by giving voltage. And do you see that the capacitor has now plus and minus charges? This is a charged capacitor. Then I take it out from my battery and see what happens right now. I will connect it to the bulb, right? Ready? So what is the bulb doing right now? It is, or the capacitor, it's discharging, right? Do you see the charge is slowly going away? And do you see that the lamp is slowly dimming out, right? So this is what happens. Now, where would you use this? Flash. Flash to the ছবি overexposed হয়ে যাবে. Yeah, car headlights. cabin lights use করতে পারো কার, তারপর হচ্ছে এটা হচ্ছে as far as I know they use it in hallway lights. এটা I have not seen in Bangladesh. So basically energy saving lamps পাওয়া যায়. They're motion sensor based. So let's say you're walking through a corridor, right? But there are these motion sensor lights out there that once you walk close to them, what do? They trigger, and then as you walk past them, they slowly turn off, right? So we can use for a HUD. It's basically smart lamps. They can detect movement and they turn on and off based on that, right? Okay, this will be fine. But I want a camera flash. Bolo ki korbo? I'll increase the area and decrease the decrease the area and increase the separation. Is that what you want for a camera flash? So camera flash, you want the discharge to happen in what time? Very short time. If you have a lot of charges, it would take a short time or a long time? Long time, right? Try kori amra dekhi ki hoy. So that's like instant, right? Aru instant kora jay, but this is what your camera flash would be. So you can control. Do you see the same circuit, the same battery, but by altering the size, I can control the time it takes for these things to actually discharge, right? So that's the charging and discharging of your capacitor. Right. So yeah, that's some basic introduction to your working of your capacitor. কোনো question থাকলে আমাকে বলতে পারো। So what happens is this is positively charged, this is negatively charged, right? Once you connect it to the plates, the positive terminal here will attract electrons out from here. So as the electrons move out from here, this thing becomes what charge? Positively charged. But electrons to chole jacche ekhane and they're positively charged. So this plate will repel electrons here to that place. Also, the electrons will get attracted to that. So basically, the electrons are bound to get to that place. Okay. Right. So, question. There was a question here. Are they efficient capacitors? Absolutely not. That's by design. Even if you have the best capacitors ever made, mathematically their efficiency is 50%. But 50% is possible. So it is not really good in an energy storing process. I mean, I can see IC students down the line, they'll go like, why aren't we storing electricity in capacitors? Is electrical storage is the problem. But when surplus electricity from your power station, what do you do with it? It just goes to waste. There's nothing to do about it, right? So some students will go like, let's store them in a capacitor. So what's the problem in storing in a capacitor? Number one, তোমার যে 100 joules surplus থাকে তুমি স্টোর করার সাথে সাথে how much is it? 50. That's given that there's no what happening, energy loss. But of course energy loss হবে. So it goes down to like 30, 40 ওরকম level চলে যায়. On top of it, there's something called the charge leakage. So আমি যদি একটা capacitor নেই and I keep it charged and I keep it on a table, right? Will it stay charged forever? Like slowly it'll start to leak the charges. Yeah, it'll leak the charges. It'll discharge within like a couple of days. Okay. So school jodi tomra kono shomoy use koro capacitors. Have you done practicals of capacitors? No. Right. So what you do is you're given a capacitor. How do you know it's charged or not? You don't know. So simple practice is whenever you have capacitors in the school or kono jagay, the first thing anyone does with a capacitor is take one terminal and connect it to the other terminal. And the moment you do that, what does the capacitor do? Discharges and it becomes neutral. Because I want to the charge thakto, wouldn't there be some charge on one plate and not on the other plate? By doing so, am I not letting all the charges move around? And they will only stop moving around when the net charge is what? 0. So that's how discharge is. So capacitor use for discharge so that you know কোনো residual charge and that will make your experiments more reliable. Okay. Right. So
first battery charge at one place.
Right.
And then when you are removing the battery, how do you ensure that something will go back to neutral?
The charge only goes to the
charge doesn't go back to neutral.
So you take this. Well, practically, if I'm talking about, you just take the battery out, right? So if I take the battery out, can the charges go back? No, there's a gap, right? And then I fill the gap with what? Okay. Or you can do this, which is what they do in lab. It's called a two-way circuit. There's a switch here. This charges it. This charges it. Right, so some basic information about the capacitors যা chart to copy করে নাও, page 108. Aajke the main idea was to explain to you the fundamentals of the capacitor. Next class we'll learn the charge and discharging process in detail, and then we'll learn the equations and math. You also have series parallel combination in Cambridge, okay, like how to combine capacitors. Not difficult. এই চ্যাপ্টারটা কিন্তু খুবই ইজি। এটা shouldn't really bother anyone. Unfortunate ব্যাপারটা হচ্ছে question দেয় না ওরা, তো মানে খুবই rarely question আসে। যদি চলে আসে তখন তো অপশন নাই। এটা না, টেস্ট হচ্ছে তোমাদের নেক্সট টেস্ট হবে অন এন্টায়ার থিং দ্যাট উই হ্যাভ ডান সো ফার। হ্যাঁ, ডিসেম্বর হচ্ছে ফার্স্ট উইকে। হ্যাঁ, তার জন্য ওই টাইমে দিচ্ছি আমি, সো দ্যাট ইট ম্যাচেস। তোমাদের সিলেবাস তো সেম, তোমাদের সিলেবাস থাকবে টিল এসি কারেন্টস, রাইট? এই কোয়ান্টাম, হ্যাঁ ওকে। আমি চেষ্টা করবো টু ফিনিশ ম্যাগনেটিজম বিফোর ইউর এক্সাম। কোয়ান্টাম তোমাদের থাকে না, বাট কোয়ান্টাম না, কোয়ান্টামটা নর্মালি দেয় না জিপিএস এ। Have you started magnetism? তাহলে তো কোয়ান্টাম তো দূরের কথা, নিউক্লিয়ার দিয়ে দিবে। অ্যাস্ট্রো, nuclear physics. So from the start you guys did like parts and parts, so বাকি সব হয়ে গেছে। Oscillations, তারপর হচ্ছে ideal gases, done. There's a magnetism শেষ, but you guys were just doing capacitor like last week. পরীক্ষা হলো না একটা, করাই ফেলছে। The problem is the school. The school forces teachers to do this. Teachers actually dosh na. They'll give them like a teaching plan. Teaching plan এর মধ্যে লেখা থাকে every day একটা chapter. I don't think this is how it should be, but করতে হবে। IB, like teaching IB, I don't think IB teach করা লাগে। It's very organic, যেভাবে শিখায়। To teach হচ্ছে যেখানে কোনো পড়ালেখা হয় না, মেবি আইএসটি or mastermind. I don't like the 9 to 5. I like the 5 to 9. Just relax, enjoy my life. Yeah, it's self, it runs on its own. Yeah, it's the software. I just have to maintain it, which doesn't need any maintenance. Are you guys done? Okay, so a Wednesday, but I think Saturday. I told I'll take an extra class, right? So I'll let you know class route. So maybe Wednesday then so I'll take extended class. Right. So next class we'll be doing the rest of capacitors.